Hi everyone. So today we're going to carry on with what we were doing yesterday. So yesterday we did question 11 and question 12 from the paper 2 2021 AQA A-level maths paper. So these were two mechanics questions that we did yesterday. So we did question 11, question 12, the two multiple choice mechanics questions. Today we're going to do question 13 from this paper 2 2021 exam. And it's this question here. So we've got a vehicle with a total mass of 1,200 kilograms is traveling along a straight horizontal road at a constant speed of 13 meters per second. So then the vehicle begins to accelerate at a constant rate. Okay, so first thing that I'm going to mention right now. So when you see a vehicle accelerating at a constant rate, constant acceleration, this is SUVAT. So it's telling you automatically this is going to be SUVAT. So our SUVAT equations we can only use when the acceleration is constant. So when you see constant acceleration or constant rate of like accelerating at a constant rate, you want to think, right, this is a SUVAT question. So I know it's going to be a SUVAT question. So after 40 meters, it reached a speed of 17 meters per second. Find the resultant force acting on the vehicle during this period of acceleration. So remember our formula for resultant force, that's F equals ma. So F equals mass times acceleration, and where capital F is our resultant force. We've got a mass of vehicle, which is 1,200. And then we want to times that by acceleration, and we don't know the acceleration. So yeah, that tells us we're going to need to use SUVAT to find the acceleration. So let's see what data we've got. So we've got a constant speed initially of 13, and then it begins to accelerate. So I know using my SUVAT letters, our initial speed u is going to be 13. We've got an acceleration that we don't know, so I'll just say that a is the question mark. We don't know the a. 40 meters, it reached a speed of 17. So right, so we've got a displacement of 40 meters. So it's traveling along a straight road and it's being displaced 40 meters. And the final speed it's going to end up at is 17. So v is 17. So then now we can use our SUVAT equation. So we've got u, we want a, we've got s, we've got v. So we want to find the equation or use the equation in the formula book that doesn't involve a, and that's going to be this one. So s, sorry, my bad, wrong way around. V squared equals u squared plus 2as. So that's the equation that we're going to want to use. And we want to find the a. So actually what I'm just going to do is actually just rearrange this formula to make a the subject. So we get v squared minus u squared equals 2as. Divide both sides by 2s. We get a is equal to v squared minus u squared over 2s. So now we can just plug in our data into this formula to get our acceleration. V squared, 17 squared. So 17 squared is 289, I think. I've not got my calculator with me, which is a pain, but I think it's 289. U squared, so 13 squared, that's 169. Divided by 2 times the distance, so divided by 2 times 40, which is 80. And so we're going to get 289 take away 169. So that's going to be 120 over 80. And if we do that, we should get 1.5. So we've got an acceleration of 1.5 meters per second squared. So that means our resultant force using our F equals ma up there. So resultant force is going to be 1,200 times by 1.5. And that's going to give us 1,800 newtons as our final force there. So that answers that question. So that was just, yeah, this question was just a mixture of using F equals ma and also SUVAT as well to get the acceleration in our F equals ma formula.